Hello everyone, I'm James. Today my partners Emily, Neil, and I will introduce Very Large Telescope to you guys. In this topic, we'll talk about some simple information about Very Large Telescope, such as location, purpose, design, and why build Very Large Telescope. Now let's begin. I will tell you the location, purpose, and function about Very Large Telescope. The Very Large Telescope, built by the European Southern Observatory of 8 European countries. In addition, Very Large Telescope consists of 4 individual telescopes. The 4 telescopes are combined to observe and become the world's largest optical telescope. Next, location. The Very Large Telescope is located in the Atacama Desert northwest of Chile, South America. More specifically, the Very Large Telescope is located at an altitude of 2,635 meters stereo parallel, which is the home of Parallel Observatory, 120 kilometers south of Antofagasta. The Very Large Telescope stands in the Atacama Desert because the driest area, making it ideal for astronomical observations. Next, purpose and function. Like other telescopes, the Very Large Telescope is an extension of the human eyes to observe and explore every corner of the universe and understand the mysteries of the vast universe. The main wavelengths of Very Large Telescope operate visible and infrared wavelengths, which are about 300 nanometers to 20 micrometers. The reasons why Very Large Telescope operates visible and infrared wavelengths due to some advantages of them compared with other electromagnetic spectrum. First of all, visible light wavelengths passing through the atmosphere can overcome many challenges, avoid atmospheric obstruction, and absorb most of portion of the electromagnetic spectrum. Secondly, infrared radiation can through the atmosphere, while the longer wavelengths are blocked. In addition, everything that has heat emits infrared radiation, including telescopes. So a Very Large Telescope operates visible and infrared wavelengths among the EM spectrum to detect objects. Next, I will give it to Leo. Welcome to Leo.
Hello everyone, I'm Leo. Now I'm going to talk about the design of the Very Large Telescope. The Very Large Telescope consists of 4 telescopes with a mirror diameter of 8.2 meters, and 4 additional mobile auxiliary telescopes measuring 1.8 meters in diameter. By combining light from this telescope causes the process of interferometry. The interferometer records the interference product by combining light from 2 or more telescopes. The basic measurement is the amplitude and phase of the divergence. This is the interferometer used by the Very Large Telescope to observe the planets. Okay. Now, I will continue to talk about the principle of the Very Large Telescope technology. The Very Large Telescope uses an active optical system compared to other telescopes. That applying controlled forces to the primary mirror and in moving the secondary mirror in order to cancel out the errors. And the active optics is a wavefront correction technique used to eliminate the deformation of the optical system and the support of the telescope caused by factors such as gravity and temperature. And as a small portion of its beam is direction through the screen mirror to the 4 quadrilateral dials used to measure the position of the laser beam, and the other is used to measure the direction on the focal plane behind the lens. Now, my teammate Emily will introduce the research projects.
Hello, I'm Emily. Now I'm going to talk about the research project and justification of VLT. First, let's see the research project. The supermassive black hole. VLT observed the central parts of our galaxy in the near and far wavelengths. In the observation, 28 stars have been tracked. They are moving rapidly, orbiting a common invisible point. Astronomers thus then concluded this point is the supermassive black hole, and its mass is about 4 million solar mass. Additionally, astronomers from the European Southern Observatory also derived the distance between galactic center and the solar system, which is 27,000 light-years. Sagittarius A star is a bright astronomical radio source at the center of the Milky Way. It is likely the location of a supermassive black hole. In this photograph, we can see Sagittarius A is marked by the orange cross here, and S2 is a bright star near it, this one, orbiting it with a period of about 16 years. Next, I would like to talk about the justification. VLT is a world-leading telescope. Following are some good reasons for investing in VLT. Firstly, to improve efficiency. Secondly, to enlarge spectral coverage. Thirdly, to provide some quantitative analysis of spatial performance. And lastly, to let VLT has a substantially longer lifetime. In addition, other countries can also access to VLT through the international partnership for their research. For example, the Australian National University. Last of all, the outstanding design and its remote location may be attractive for movie filming, such as the spy film of James Bond series.
We're about 2 hours east of Antofagasta, which is on the Chilean, North Chilean coast, in the middle of nowhere. Up how many feet up? About 10,000 feet up over here?
We were lucky enough to be accepted up there, really, because it's a research centre. So we were very privileged to be filming up at the observatory and using it for one of our key locations in the movie. It's a stunning place.
For VLT, these can be the income sources and also raise its prestige. To conclude, VLT is used for research around the world, and it has a high prestige of being the world's top telescope. Alright, this is the end of our presentation. Hope you guys know more about VLT now. Thank you.